Good morning. Today's session we will discuss about the combinational logic circuits. Outline of this today's session: introduction about the combinational logic circuit, design of combinational logic circuit for the given scenario, and we will discuss about some combinational logic circuits that like adder, subtractor, comparator, multiplexer, demultiplexer, decoder, encoder, code conversions. So introduction about the combination logic circuits. So generally logic circuits are classified as combination logic circuit and sequential logic circuits. So combination logic circuits is a logic circuit whose outputs depends only on the current inputs. That circuits does not have any memory. Sequential logic circuits which has a memory. In the type of logic, it is a type of logic circuits. Output depends upon the present input and previous inputs. These circuits have a storage element and a logic gates. Design methods. The logic circuits are designed by different methods. So first one is a small scale integration, SSI. In which up to 12 gates are accommodated. In the medium scale integration, 12 to 99 gates are available. In large scale integration, so 100 to 9999 gates. Very large scale integration contains 10,000 to 99,999 gates. Ultra large scale integration, that is ULSI, has more than 1 lakh gates. So objective of the logic circuit is for the low cost, reduce the number of gates, reduce the IC packages, increasing the speed, simplicity of the logic circuits. Then applications of combination logic circuits. Combination logic circuits are used for arithmetic and logical functions, for data transmission, and for code conversion purpose. So for arithmetic and logic functions are adder, subtractor, comparator, incrementer, decrementer. And for the data transmission purpose, the multiplexer, demultiplexer, encoder, decoders are used. Code conversions are binary to gray code, gray to binary, BCD to XS3 code, XS3 to BCD, and BCD to 7-segment display converter. So these are all the some combination logic circuits. Yeah, combination logic circuit consists of input variables, say n inputs, and logic gates, and some output variables. For n input variables, there are 2 power n possible input combinations. For n possible input combination, there is only one output possible combination. A combination can be described by m Boolean functions, one for output variable. Output function expressed in terms of n input variables. Design procedure of combination logic circuits. To design a combination logic circuit, first we want problem description. Then second step is we have to specify the number of inputs and number of outputs required to specify for the specifications. And then we have to assign input and output variables as a letter symbols. Then construct the truth table to define the relationship between the input and the output. From the truth table, we have to derive the Boolean function, simplified Boolean function for each output by using a K-map, tabulation method, or by using Boolean rules. After getting the reduced Boolean function, we have to draw the logic diagram. Practical design. Yeah, practical design methods would have to consider such constraints such as minimum number of gates, minimum number of inputs to gate, minimum number of interconnections, minimum propagation time of the signal through the logic circuit. simple design of a OR gate. Example, simplify two input OR gate. This is the statement. For this, we have two inputs and one output. For two input and one output, we have to draw the KMF in the truth table. In the truth table, X, Y are the inputs, F is the output. F output is equal to 0 when all the inputs are 0, 0. Otherwise, the output will be 1. So, for this truth table, we have to draw the K-map. Two variable K-map. X, Y are the input, F is the output. So, after that, we get a Boolean function F is equal to X plus Y. Then draw the circuit or OR gate symbol. So, one design of combination logic circuit for the given scenario. The given scenario is a committee of 3 individuals decide issues for an organization. Each individual votes either yes or no for each proposal that arises. A proposal is passed if it receives at least 2 yes votes. Design a logic circuit to determine whether proposal passes. For this scenario, solution is here we have 3 inputs and 1 output. So 3 inputs are called as X, Y, Z and proposal output is F. So from the scenario we have output is 1 when 2 or more inputs are 1. Otherwise the output is 0. So we drawn the truth table shown like that. From the truth table, we have to draw the 3 variable K map containing 3 input variables X, Y, Z and the output F. So we have a 3 pair of groups in the K map. Then the output function F is equal to XY plus XZ plus YZ. For this simplified Boolean function, we have to draw the logic circuit. So that for the design of combination logic circuit, first of all, we will specify the problem. From the specification, we have to decide how many inputs and how many outputs required. After that, we have to assign the input variable and output variable as a letter symbols. Then form a truth table that shows the relationship between the input and the output. From the truth table, we have to draw the K-map and get a simplified Boolean function for each output and draw the logic circuit. Then adder. Digital computers perform a variety of information processing tasks. Among the basic functions encountered are the various arithmetic operations like addition, subtraction, multiplication, division. Here we will see about the binary arithmetic. The rules for addition are 0 plus 0 is equal to 0 as a sum and 0 plus 1 is equal to 1 as a sum. 1 plus 0 is equal to 1 as a sum. Here 1 plus 1 is equal to 0 as sum and 1 as a carry. Binary adder, that is a half adder. Our aim is to design a combination logic circuit that performs arithmetic operations for adding 2 bits. So the input is equal to 2 bits, n is equal to 2 bit. So 2 power n is equal to 4. 4 input combinations are available and output is equal to 2. That is one output is sum and another output is a carry. So that from the addition rule, we have a truth table for the half adder. Inputs are x and y, outputs are sum and carry. If both inputs are 0, 0, sum 0, carry 0. If the inputs x equal to 0, y is equal to 1, sum 1, carry 0. if the input x equal to 1 and y is equal to 0, sum 1 carry 0. If both inputs are 1 1, sum is equal to 0 and carry is equal to 1. So next we draw the K-map for getting the simplified expression for sum and carry. So we can get a carry is equal to xy, sum is equal to x bar y plus x y bar. For this simplified sum and carry expression, we have a logic circuit. So for sum, we need a one XOR gate, and for carry, we need one AND gate. Next, binary adder, which adds 3 bits at a time. So that is called as the full adder. Design a combination logic circuits that performs arithmetic operations for adding 3 bits. Here n is equal to 3 bit, that is input is equal to 3 bits, and 2 power 3 is equal to 8. So 8 input combinations are available, and output is equal to 2, sum and carry. So input x, y, z, and output sum and carry. So based on the rules of binary addition, if any 3 inputs are 0 0 0, output sum 0, carry 0. If any one of the input 1, the sum is 1 and carry is 0. If any 2 inputs are 1 1, sum is equal to 0, carry is equal to 1. If all 3 inputs are 1 1, sum 1 and carry 1. For this truth table, we have a 3 variable K-map for sum and carry. So sum is equal to, you can get the expression x bar y bar z plus x bar y z bar plus x y bar z bar plus x y z. And for carry is equal to xy plus xz plus yz. For the two simplified expressions sum and carry, we have a logic circuit. Subtractor. Digital computers perform a variety of information processing tasks. Among the basic functions encountered are the various arithmetic operations, that is called as the subtraction. The rules for subtraction is 0 minus 0 is equal to difference 0, 1 minus 0 is equal to difference 1, 1 minus 1 is equal to difference 0, 0 minus 1 is equal to, we cannot subtract, so we can get a borrow. So borrow 1, after getting borrow, the difference is 1. So like a binary adder, that is half adder and full adder, based on the subtraction rules, we have to design a half subtractor and a full subtractor. Half subtractor is used to subtract 2 bits. So in that half subtractor, we have 2 outputs, difference and borrow, 2 inputs and x and y. So like adder, we have to design a subtractor also. So full subtractor has a 3 inputs and 2 power 3 is equal to 8 input combinations, and we can get the output bar on the difference. Like full adder, we have to design a full subtractor also. By using a 3 variable K-map, we can get the difference and the borrow equations. After that, we have to draw the logic diagram. Comparator. A comparison of two numbers is an operation that determines if one number is greater than, less than, or equal to the other one number. A comparator is a combination logic circuit that compares two numbers A and B and determines their relative magnitudes. The outcome of the comparison is specified by 3 binary variables that are A greater than B, A equal to B, or A less than B. So that is one example. Design a combination logic circuit that compares two 1-bit numbers, that is A and B. So A0 is 1 bit and B0 is 1 bit. We can get the 3 outputs, that is A equal to B, A less than B, A greater than B. So by using this truth table, we can get the 3 simplified expression, A equal to B, A less than B, A greater than B. After that, we have to draw the logic circuit. Okay. So next class we will see about the multiplexer, encoder, decoder circuits. Okay, thank you.